Today we continue to work on our typing trainer tool. Last time we defined our main loop. We have this Ratatui library running practice sessions in its internal loop. And today's episode is all about this app draw, which currently does nothing but simply shows us the text that we want to type in. It disregards the user's input. It does not center the text in the terminal, and it doesn't show you whether the characters were typed correctly, incorrectly or not. And this is everything that we are gonna fix, so to speak, today. Now, the main thing here is the draw function. Right now it does nothing but shows us the target text. So anything user might have typed in, it simply disregards that. And let's actually target this particular part. So in order to show what the user has already typed, what mistakes he has already made, if any, and what's left to type, we need to somehow build our internal state from those target text and input text. We can do that by asking our state to build a page. This is of course non-existent method yet, so let's generate the method, jump into it, and this method is going to return a page. What is a page? Let's define a public type saying that page is nothing but a vector of lines. Now we're missing the definition of line. We can also define it here that line is nothing but a vector of characters. And now the character type is missing. For that, let's define new module, name it character. Let's create that module and define an enum named character. Let's derive debug, and here we will have three different values for this enum. First of all, we'll have something for correctly typed character, and we'll call it hit. Then there will be incorrectly typed character, which is of course miss. Finally, untyped character we will define as empty. And now we can jump back to our state, import the character. So we're saying that our build page method is going to build a vector of lines, where each line is a vector of characters, and each character is going to represent whether this character was typed in correctly, incorrectly, or it hasn't been typed in yet. So let's start working on this build page method. First of all, we need to grab our lines from the target text, which we are supposed to type. We can do it self target lines collect. Right, so this is going to be back of string references. Then we have input lines. So these are the lines of the text that user has already typed in. And then we would like to compare or zip or join the those inputs line by line, meaning we take the first line from target and put it together with the first line from input and compare character by character whether it was typed in correctly or not. To achieve that, we first need to make sure that our input line's length is at least equal to target line's length. And if it's not, we would like to push some empty strings, empty lines into it. So we can push For that, our vector needs to be mutable. So after this while loop, we are quite sure, we're confident that input lines has at least the same amount of lines as our target lines. And that is all that we need to do the next thing. So really building a page is nothing but grabbing our target lines, its iterator, we're gonna zip it with our input lines iterator, and map and collect. So when we're mapping, right, what we get here is a tuple of reference, so we can do it like target and input, where target and input are string references, and we can say that, hey, let's self build line from target and input. So what did we do here? Pretty much we just combined the lines. So first line from target combined with first line of input, second from target, second from input. That's exactly what zip does. And then we are trying to grab those lines and combine them into a single line. So we will have another function here named buildLine, which works with target string reference and input string reference, and it will return a line, right? And the line is nothing but a vector of characters. So let's add to do. Seems to be fine. So build page is the way it should be. So now we have two lines, and we would like to compare things character by character. The problem here is that target and input length can be different. So what we should do is somehow make them equal. Let me show you how we can do that. So let's define target chars as target chars. So we are handling UTF by calling chars here. What can we do then? We can then map it to sum. So we're converting it to option. And then chain repeat none. And repeat must come from std iter repeat. So now target chars is nothing but an endless iterator which has initially sums of chars from target and then endless amount of nones. So don't try to call collect here, because yeah, Rust will try to reserve maximum memory for that and it will fail. So because it's an iterator, we haven't actually went through it, so this is fine. We need to do the same thing for input chars. So we grab all of its chars, we convert it to option, we chain it with endless nones in the end. Final thing that we need is max length, which will be target chars count max input chars count. So we're taking the length of target in UTF characters, and then we take the input length in UTF-8. That's why we're using chars here. Compare those two counts, pick the maximum of it. Now we know which one of these, right, either target or input, is longer. Finally, what we can do is probably drop this to do, and we can then grab target chars, we can zip it with input chars. So as you remember, this is like endless iterator, this is endless iterator, and the result of zipping them is still an endless iterator. So really, we can't call collect on it yet. But here is the trick. As we know which of these was the longest, either target or input, we can actually tell our iterator to only take the max length amount of characters from it. Then we can do some magic with map and finally call collect. So what are we doing with map? We receive a tuple of option chars. Right, so let's define it like this. So it's going to be T and I, which stands for like target char, input char, and we can call some method. Let's call it like classify character ti. So this is the method. Let's add it to our character model. Public function classify character, which grabs target option char and input option char, and it gives us back a character. So this is the function that is going to compare target and input, and it will tell us whether the character was typed incorrectly, or it hasn't been typed yet. We can import this classify character here, and build page with build line is now complete. So we need to address this function, classify character. Let's match on this tuple, target and input. First of all, in case both target and input have something, so there is a character in target and the user has actually typed something at that position. If target character and input character are the same, we are sure that this is a hit. We need to probably do it like this. Next, in case target and input have something, but they are different, it means it was incorrectly typed, so it's a miss. And in this case, when T and I are the same, we are saying hit from T, but really it could be hit from I. Right? It doesn't matter because they are the same. But when it's a miss, which means that it was an incorrectly typed character, we need to store the I, so the character that the user typed, not T, right, which we no longer need here, because we want to display the character that the user typed, and because it's a miss, we would like to show it in a way that indicates that, hey, this is a mistake. Let's see. In case target has no more characters and our input has something, which means the input is longer than the target, we can tell that it's again a miss, so you typed more than required. In case target has something but there was no input from user for that position, we can tell that this is actually empty for T. And other, which is like none, we can just panic saying unexpected character classification, which really like shouldn't happen. We don't expect that to ever happen with what we did here because of this max length, and we take it right here. All right, so this is how we built our internal representation of the state. Right, so this build page was called from the app. Now this is internal representation. There is no way for us to show it yet. So what we can do is we can convert it into Ratatouille's widgets. So let's do just that. We can say that lines is going to be an empty vector, and in this case lines is going to be representing Ratatouille lines, not our internal ones. Then we can say for line in page header. Right, so currently line is a vector of characters, so this is our internal representation of the line taken from the page. So for each line of our internal state, we can say that, hey, let spans vec is going to be something, and then lines push line, which is now, as you can see, Ratatouille, from those lines, from those spans. This requires lines to be mutable, and then we need to see how we can convert a line into a vector of spans, where span is just a, I think, widget from Ratatouille. So let's see. We have a line iter map. We have a character here, right? Reference to character. We can say self render character and collect. So what's missing is this render character method. Let's add it right here. Render character self, and character is a reference to our character. And what it is going to return is going to return a span, which is a Ratatouille's thingy with some lifetime, whatever the compiler decides it is, right? So what is a span? It represents a part of a line that is contiguous and where all characters share the same style. In our case, each character is going to be represented as a single span. This is, of course, a part that can be later on optimized so that we can pack the characters with the same style into single span, but for now it's enough to have every single character to be in its own span. Next, in order to render the character, we need to first understand what kind of character we are dealing with. Right, fill the arms, so it can be hit, miss, or empty. So in case it's a hit, meaning that user typed the character correctly, we can say that this is going to be a span raw c2 string. Pretty much raw just tells us that span with the default style. It will use the default terminal style without applying any extra styling of our own. Next, in case it's a miss. Now we would like to show it a bit differently. We would like to somehow indicate that this is an error, so most likely show it in red color and somehow highlight it even more by applying bold modifier. So we want the character to be red and bold. To do that, we can use span styled, right? So creates a span with a specified style. Content is again c2 string, that's our character, and the style, again we need to grab the Ratatouille style. Let's grab default. We can apply foreground with some color. We'll see which color, and then add modifier which is bold. So we need to add the color here. So as I said, because it's a mistyped character, we would like to have this character to be red. Instead of hard coding the red color right here, right now, we are going to use self config foreground miss. So as you remember, when we're creating the app, we are passing state and config, but we disregarded config, and right now we will actually use that. So we need to say that, hey, config is actually, it's a reference config. Now it complains about lifetime because it's a reference. Let's add one. And now it complains that implementation also requires the lifetime param. Let's add here lifetime as well. So now it no longer complains about self-config, but it does tell us that this param foreground miss is not there. Let's add it a bit later. First of all, let's see how we can handle the empty character as well. So this is a character that hasn't been typed yet. We don't want to make it bold. We don't want to highlight it with red. What we do want to do is to show it in a grayed out kind of style. So again, we will use span styled, where we show C to string, and this style is going to be again default with some foreground, where color is going to be self config fg empty, right? Except that it needs to be of type color and not something that we are going to be passing straight from config. So we first need to tell it color. I think it's indexed. Let's see, we need to use the Ratatui style color, right? So indexed is pretty much an ANSI color, 8-bit, 1 byte. That is an easier thing to pass through the config and then override it with command line arguments rather than encode the full color type into the config. So the same must be applied here, color indexed. All right, so this looks good enough. Let's work on the config. We want to have what? We want to have pub foreground empty, which is a new 8-bit, 1 byte, pub fg miss. Right, so this is going to be ANSI color for incorrectly typed character, and this is ANSI color for untyped character. Now, if we look at ANSI colors terminal, let's open something that contains, this is a very nice picture. So this is something we're going to use. As we can see, 1 is this nice red. Oh, we can use 9, but 1 is a bit better. And 8 will have us this grayed out kind of color. So when we create the default config, which is hard-coded for now, later on we will add this command line argument parsing, which will allow us to override things. For now, we can say that if it's incorrectly typed, it's going to be 1, and in case it was untyped, it's going to be 8. So these ones are now working as intended. All right, so if we run our program, nothing has changed. Why hasn't it changed? Because even though we took our internal state as a page, we converted it into Ratatui lines, we are still showing simply the text of our target right here. So let's change that. We can simply pass our lines right here. Let's run it, and we can instantly see the difference. Our text is now grayed out. That is because our user's input is currently empty. So when we create our state, we have target as our text, and the input is currently empty. So what we can do to test things out is we can actually open our text and grab this initial thingy, put it into the input, right, and make a few mistakes. Instead of this, we can do thus, beer, we can type beer, minimum, we run it, and we can see that the errors are now red and bold. the untyped characters are like grayed out, and the correctly typed are simply using the default style of our terminal. So two main things are currently missing here. First of all, we don't know where our cursor is. Is it at the space position? Is it at E position? We don't know, so we must make sure to show the cursor. And secondly, of course, we want to make sure that this text block is somewhere in the center of our terminal. All right, so yeah, I can probably show a third thing that is missing. So if I made a mistake in thus, currently there is one error. Instead of this, I typed thus, but what if instead of S, I typed in a space? If I run it, we need to indicate that there is an error. You typed in the space, but there should be a different character there. And we don't do that. Why? That's because, was it an app? That's because when we are showing the space itself with the styling of red and bold, there is nothing to show. We can change that by saying that if our C is space, right, then we can display this underscore to string, and else we display the character that was incorrectly typed. Run it again. Yep, we can see that there should have been an S, but there is a space, and it shows you an underscore that, hey, you typed it incorrectly. All right, so what should we do first? Should we add cursor, or should we centralize our text? Let's add the cursor first. So once the text is rendered, we would like to position our cursor at the correct spot. And we do that only when the typing session is actually in progress. So if self state, what do we have, is complete, so we need to negate that if it's not complete yet. We can tell that let cursor row cursor column equals self state cursor, so something that we need to add. Then we can tell that cursor X, or horizontal position, needs to be frame area X plus cursor column. Then Y, vertical position should be frame area Y plus this one. Then we can use set cursor position, which is a tuple, cursor X and cursor Y. So what do these lines do? What kind of magic do they perform? First of all, we need to define a method that will return the position of our cursor. It should return the row and the column where it should be. Next, we take the area. Currently, we are drawing in the area which represents the whole terminal window, and that's subject to change as we start centralizing our text block. For now, the whole area, it has a height, width, it has an X and Y, which are probably zeros right now because it's a full area. It's not some smaller area somewhere in the terminal. So we add column to get the X, we add row to get the Y. So let's first work on this cursor method. It should return something like uSize, and we will use some methods like cursor row and cursor column. Right, so two methods that we want to add: row, which will return an uSize, and cursor column, which will also return a uSize. So how do we find which row we're currently on? It should be as easy is taking self input chars, right? We grab all the characters that we have already typed in, and then we can filter the character, and we find all the new lines and simply count them, right? So think of it this way, is that if it's the first line that we are typing, there is no new line yet, we are on the row number 0, which is correct. Once we moved to the first to the next line, so line 2, we will have a single new line present, which we will find, will count, and the index is going to be 1, and so on. A same kind of trick can be applied to finding the column. We can take the input, all the characters that have been typed in by the user, but then we reverse them, so we start from the end and we do the filter, not the filter, let's do take while. See, the character is not a new line, and then we count them. So what we do here is we start from the end and we count how many characters are typed in on this line. Right, so as soon as we see that there is a new line, it means, okay, all the next characters belong to a different line. So that should be pretty much it. Here it complains that we have view size and it works with U16. Let's run it, and correctly the cursor is shown right after the minimum. If we adjust our state and add the space here, run it again, then our cursor is at the start of example word, which is great. So the thing that we now need to do is to actually centralize this paragraph. To do that, we need to use layouts provided by Ratatui. So let me show you how we can do it. First of all, let's try to center it vertically. So we can say vertical layout. This is Ratatui layout, vertical, and it expects some constraints, which we can give him as constraint. It was, I think, length, vertical margin. So this is the amount we want to skip on the top. Then it's going to be constraint length of text height. So the amount of lines we want to show. And the final constraint will be minimum 0, which tells us that at least it will be at least 0. So we never know whether there is vertical margin. Sometimes due to number of lines not being even, it can be just a tiny bit less than the top margin. But this pretty much says that let's break down the layout vertically into 3 different areas. The first area, the top one, will be of height vertical margin. The next one will have height of text height, and the next one is going to be the remainder of the free space. Technically we want it to be the same as vertical margin, but due to how the number of lines in terminal work, it might be just a tad bit smaller. So we're currently missing these things. Text height is nothing but lines length, I think. It still complains because it needs to be U16. Right, so the lines is what we built. We know that we need to show this amount of lines when we converted our internal state into Ratatui lines. Next, vertical margin. What is vertical margin? We need to grab the area. We need to grab its height. So this is like from top to bottom. Next, we need to sub, and not simple sub, but saturating sub, so that we don't go into negatives, and we can sub the text height. Right, so imagine that our terminal is, I don't know, like how many, like 70 whatever, 40 lines. Right, its height is 40 lines, and the text height is, I don't know, 5. So from 40 we need to subtract 5 and divide it by 2. Why are we dividing? It's because we want to have top area and bottom area to be the same. So that's the way we got the vertical layout. Now we need to actually apply it. How do we do that? We can say that something is vertical, vertical areas from what? From frame area. So pretty much we're saying that let's apply these constraints, these layout constraints that we just built, to frame area. And frame area is initially our whole terminal window. And it will return a rectangle for each of these constraints that we defined. That's why we have 3 constraints and 3 areas. And we are only interested in this, let's say, middle area. Now we need to actually render our paragraph into the middle area instead of the frame area. And for cursor to work, we also need this thing to be rendered into the middle area. Let's run it. And our text is currently in the middle. So it took the whole height, subtracted those 3 lines, right? So it received all this free space that is outside of these 3 lines, divided it by 2, so that we have half of it here and half of it down here. So next step is to take this middle area and apply a horizontal layout breakdown to it so that we centralize our text. Let's do just that. So horizontal is layout horizontal with some constraints. Let's copy these constraints right here, except it's going to be horizontal margin. And what kind of length should it be? It should be max line length, right? We have multiple lines. We have like however many we built here. Each of them has its own width. Yeah, let's name it width, maybe. Or length, doesn't matter. And we want this whole section to be able to contain the maximum line width. That's why we have this constraint here. All right, let's build it somewhere over here. The max line width is what? It's going to be lines. Let's grab iterator, map. Each line has width. Probably easier to cast it right here, and we take maximum from it. Right, so all the lines that we have, we convert them to line width and take the maximum of it. But maximum actually returns option, not because, well, lines can be empty, so we can do it unwrap or 0. So in case, just in case, right, lines are empty, we can tell that max line width is actually 0. So what's left is our horizontal margin. Let's calculate it. Horizontal margin is again nothing but frame area width, so the width of the whole terminal, saturating sub of max line width, and divided by 2. Same reasoning, so that we take the max width, subtract it from the whole width, so that we know how much free space is there, divided by 2, so that half of it is on the left, half of it on the right. And now we need to tell that, hey, horizontal areas, so apply this constraint to middle area, right? So middle area is already a rectangle that is referencing only this middle area, not the whole terminal window. Again, we had 3 of those areas, right, defined here. And we're only interested in the middle one, which we'll call centered area, something. Right. So we substitute things so that they are actually rendered into this centered area. Let's verify it. And it works as expected. So right now we have our main loops ready. We are able to render things. We're able to compare the target text with whatever user has typed in. We even have set up the bare minimum for input handling, but whenever I type something, we have not yet implemented. And that is exactly what we're gonna do next time. I hope you enjoyed this episode, and I'll see you again. Bye.